Hello Legacy Savers, Marsh here. So today we're going to talk about the rational zero theorem. You're going to need your notes, calculator, and then a pen or a pencil today, and definitely you're going to need some patience today as well. So think, what will happen if we need to solve polynomial, but it isn't factorable? What would we do? And you see that little guy right there, he is super scared about this. Because this is scary. When you get a polynomial, you need to solve it, but yet you can't factor it. So we need to know another method to accomplish. So today's goal of this video is to find a way to solve polynomials that cannot be factored. So we need to find a hint. Something that can divide into the polynomial. So to find a hint, we're going to become a very educated guesser, because ultimately I'm going to have to divide a number into that to see if I can make something divide out. So we're going to use the rational zero theorem. Every rational zero solution has the form P over Q, where P is the factors of the constant, the end number, and Q is the factors of the lead coefficient, the beginning number. Okay, so just little flashback. We're talking about rational numbers, right? Rational numbers are numbers that can be a fraction. So we're talking fractions, and we're also talking integers, okay? No square roots. Okay, rational zeros do not have square roots. So we are talking like 1/2, 3/4, 2, -2, stuff like that, okay? So let's use our rational zero theorem in practice. So we're going to find the real zeros of this particular function. So we're going to first look at the factors of the end and the factors of the beginning. So got my P over my Q. So P is 8, Q is 2. So all the numbers that make 8. Well, we could have a 1 and an 8, but we can also have -1 and -8, right? So we're going to go plus or minus 1, plus or minus 8. We can also have 2. We can also have 4, right? Those are all the numbers that make 8 ultimately. Then I got numbers that make 2. So now, here's what we're going to do. We're going to compile a list of possible rational zeros. We're going to put every numerator number over every denominator number. Let me repeat that. We're going to put every numerator number over every denominator number. So first I'm going to put them all over 1. So basically I just get plus or minus 1, plus or minus 8, plus or minus 2, plus or minus 4. Okay. Now finally I need to put all these numbers over 2 as well. So 1 over 2, it's going to give me a half. 8 over 2. 8 over 2. Well, that's just 4, right? And I already have 4, so I don't need to put 4 back down there. 2 over 2, that's just 1. I already have that. And then 4 over 2, that's 2 as well. So I don't need to put those ones either. So this is my list of possible rational zeros. Possible. Definitely possible, okay? These are not all these are not all solutions. Not all 10 of those answers, okay? We only know that 3 of them are going to work. So we're going to use those possible solutions and find a list to find the zeros. So here's where that patience thing comes in. Basically, it's guess and check time. We get to try to find a number, one of those possible zeros. When I use synthetic division and put that as my solution on the outside, it needs to somehow solve to get me a 0 for the last number of my synthetic division. Let's try -1 first. So put -1. I got my x cubed column, my x squared column, my x, and my no x column. So I got 2, -5, -14, and 8. Drop the 2. 2 times -1 is -2. -7, 7. This is -7, 7, 15, Womp womp. Okay, so -1 doesn't work. We gotta try another number. Let's try 1. 1 looks like a nice number, right? So let's try 1. Okay, 2, -5, -14, and 8. Okay, drop the 2. 2 times 1 is 2. -3, -3, it's -17, -17, -9. Womp womp. Okay. Dang it. Let's try a +2 this time. So 2, maybe that's gonna work. -5, -14, and 8. 2, 4, -1, -2, -16. Definitely not gonna work. I'm gonna get really, really big number. Let's try a -2 this time. Maybe that's gonna be my luck. -5, -14, and 8. Drop a 2, -4, -9, 18, 4. Aha! Found my 0. Smiley, big giant smiley face right there. Okay? So now, rewriting this as a new function, I now have 2x squared minus 9x plus 4, right? That's technically what this is. So, I now can factor this. I can try to factor this equation now. It is a trinomial, so I'm going to go like this. Boop, boop, boop. Well, two numbers that make 2x squared. Two things, I guess. 2x and x, right? Two things that make 4. Well, I need to make 9. It's probably a 4 and a 1, right? And I probably want to get this 4 times that 2. It looks like they're both going to be negative because I need that -9. So 2x times -4, that's -8x, -1x. Yes! I have gotten -9. So if I solve each of these pieces, I get x equals, add 1 divided by 2, 1/2. And also x equals 4. Now here's the thing. This is a cubic function. That tells me I need 3 answers. Where's my third answer, you're asking? Well, it's right here. It's the number we found the 0 for. Don't forget him. He is an answer, okay? So 2, or no, not 2, -2. -2 is one of my answers as well. He's the one that unlocked the factoring possibilities for us. Let's try another example here. So let's first figure out my P over my Q, right? So that's 9/2, so plus or minus 1, plus or minus 3, plus or minus 9, then plus or minus 1, plus or minus 2. Okay, so my list of possible zeros, I'm going to go all over 1 first. So all the numerators over 1. Now all the denominators over 2. Okay. Whew. Let's try a +1. See if that works. This, okay, so I got my x cubed column, my x squared column, my x, and my no x. So I got 2, -7. Ooh, no x. Whew. Gotta put that 0. Here's the thing. If you had forgotten that, and you have been trying to guess and check, and it never would have worked. So always be careful when you set up your synthetic division, alright? Drop my 2, that's a 2, -5, -5, -5, -5, 4. Frowny face, no 0. Let's check -1. See if maybe that's my key to unlocking this business. Drop 2, it's -2, it's -9. -9. Ooh, I like where I'm coming here. Oh, it should have been a +9. There we go. 9, -9, 0, smiley face. So technically the function I'm now working on is 2x squared minus 9x plus 9. So let's go ahead and factor that. So since it is a trinomial, let's lay down our parentheses. 2x and x will make 2x squared. I need to make 9. Let's go 3 and 3. And I think I'm going to both negative because this is a positive 9. But if I look here, it's a negative, so I know the two things need to add up to make me a negative. Negative 6x, negative 3x. That's negative 9, so we're good. So if I set both of those equal to 0, I get x equals 3 halves and x equals 3. And I need one more. My last answer is this guy right here, Mr. Negative 1. So let's avoid errors, okay? 'Cause this is a very error-prone, I would say very error-prone theorem that you have to use. Be sure to list all positive and negative factors. You always want to make sure that maybe that negative might work for you. Not every zero generated by your list is an actual zero. We don't know which one works. We have to play the guess game to find which one works, okay? And I know it's stressful, and you're probably thinking, Marsh, there's got to be an easier way to do this. There is actually not, okay? There's some ways to get better hints, but we'll discuss that in a couple days' time. And with that, that's the end of this video. I'll see you later, Sabers.